Have you ever felt totally overwhelmed by a massive wall of network traffic while trying to figure out why a web application is broken? Trust me, we've all been there. Well, welcome to this explainer. Today, we're going to take the Chrome DevTools Network tab, which, let's be honest, can look incredibly intimidating, and transform it into a methodical, predictable diagnostic tool specifically for IT support engineers. You are definitely in the right place.
Picture this. You get a ticket in your queue. A user is trying to get into the system, and they write, "I click login," and literally nothing happens. The page just sits there. It's incredibly frustrating for them, right? And without the proper tools, it's basically just a guessing game for you. Do you clear their cookies? Do you go hunt down server logs? Do you immediately escalate and call the backend developers? Well, today we're going to see exactly how to solve this exact mystery without guessing and without jumping straight into complex backend code. We're going to do it just by observing the network traffic.
All right, here is our roadmap for today. 1. Intro to Network tab. 2. Configuring key controls. 3. Inspecting XHR and fetch. 4. Reading the timing waterfall. 5. Identifying cores and auth. And finally, 6. A real scenario where we debug a failed login.
I absolutely love this analogy. Think of the network tab not just as some static log file, but as a highly sensitive microphone in your own personal recording studio. It picks up every single conversation happening between your browser and the web servers. It shows you exactly what the browser asked for and exactly what the server said in response. No secrets, just the raw truth.
Okay, moving into section 2, configuring key controls. This is all about tuning our instrument before we start recording. First things first, pop open DevTools. That's Control-Shift-I on Windows or Command-Option-I if you're on a Mac. Now, I want to highlight the power of 2 tiny checkboxes at the very top of the panel. Checking Preserve Log is an absolute lifesaver. It stops the browser from wiping out your network activity during page reloads or during those wonky multi-page login redirects. If you don't check this, the log vanishes the second it hits a new URL. Meanwhile, Disable Cache forces your browser to fetch every single asset directly from the server, entirely ignoring what's saved locally. This is huge because it ensures your experience in the site exactly like a brand new, first-time visitor would.
Next up, we really need to filter out the noise. Modern web apps are incredibly noisy, loading hundreds of resources all at once. By checking Hide Data URLs and Hide Extension URLs, you instantly strip out base64 encoded assets and all that background traffic from browser extensions, like ad blockers, which, let's face it, can heavily interfere with your diagnosis. And for the really advanced hunting, you can use queries directly in the filter bar. Typing status code 4xx finds all your client errors instantly. Or try typing status code 0. That's actually a unique identifier for requests that were blocked before a connection was even established, which usually points right to a security policy issue. All right, section 3, inspecting XHR and fetch. Let's learn the language of the web.
So, knowing your HTTP status codes is absolutely crucial. Think of them as your quick visual reference guide, the vital signs revealing the outcome of every single network request. A 200 means everything is great, success. A 404 means the resource just doesn't exist. The 500 block, that means the server itself crashed or failed to process the request. But the really tricky ones for us in IT support are the 401s and 403s. Those deal specifically with identity and permissions, and we'll be digging heavily into those in just a few minutes.
When you actually click on one of those requests in the list, a side panel slides open, revealing the full anatomy of the conversation. By examining 4 key areas here, you can decode exactly what went down. The general section gives you the URL and the overall status. The request headers show what you sent to the server. This is where you'll find your authorization tokens. The response headers show the server's specific configurations. And finally, the response body, well, that's the meat and potatoes. That is the raw JSON data or the specific error message that the server handed back to the browser. Moving right along to section 4, reading the timing waterfall. I like to call this the timeline of the crime. So, if a user complains that a site is running really slow, the waterfall chart is going to be your absolute best friend. Every horizontal bar in this waterfall tells a story through a series of sequential round trips. It's almost like a relay race. It starts with resolving the domain name in the DNS lookup, passes the baton to establish the TCP connection, then does the SSL security handshake. After all that, we wait for the server to actually think about what we asked for. That's TTFB, or time to first byte. And finally, the actual content downloads to the user's browser. Now, what's really brilliant here is how simple color coding can instantly tell you where to direct your investigation. If you hover over a request timing, Chrome breaks it down into colors. If that bar is predominantly green, meaning a really long time to first byte, the server is your bottleneck. You're probably looking at a slow backend database query or an API issue. But if the bar is mostly blue, that's content download time. The issue there lies with resource size or network speed. You might just be dealing with an oversized, completely unoptimized image trying to load over a slow 3G connection.
Oh, and for those of you utilizing the late 2025 and 2026 builds of Chrome DevTools, there is a fantastic new feature you have to check out, the explicit render blocking column right there in the network panel. If a user complains that a page is just stuck on a blank white screen, this column instantly flags the resources, usually a heavy CSS file or some synchronous JavaScript, that are literally preventing the browser from drawing the page. It completely takes the guesswork out of front-end performance issues.
All right, Section 5, Identifying Cores and Auth. This is where things get really interesting.
Getting these two specific errors confused will send you down the wrong troubleshooting rabbit hole for sure. Let's clear it up. A 401 unauthorized means you lack the right key. The server doesn't know who you are, or maybe your token expired. Your very first move here is to check the authorization request header. A 403 forbidden, on the other hand, means the server knows exactly who you are, but you simply aren't on the VIP list for that specific action. You have a key, but it doesn't open this particular door. For a 403, you need to check IAM policies, OAuth scopes, or see if a web application firewall is blocking an IP address.
And then we have the notorious CORS error. The most important thing to remember here is that CORS errors are enforced entirely by the user's browser. It's a client-side security mechanism. This means your front-end request actually reached the backend server successfully, the server processed it, but when the response comes back, the browser essentially plays bouncer and says, wait a minute, the server didn't explicitly give me permission to read this data across different domains, and the browser blocks the code from seeing it.
Browsers actually check for this permission beforehand by sending a pre-flight request using the HTTP options method. So if a user tells you an API works perfectly fine in a terminal tool like curl, but fails completely in the web app, you are almost certainly looking at a CORS issue. To debug it, filter your network tab by all, find that options request right before the main failure, and check its response headers. You are specifically looking for access control allow origin to see if the server is actually permitting the browser's domain to access that data.
Okay, let's bring it all together. Section 6, a real scenario. Let's solve that failed login. Just look at the stark transformation this brings to your daily workflow. Before applying these techniques, a failed login usually meant staring blankly at the screen, clearing browser caches aimlessly, and just hoping for the best. After applying this framework, it's a calm, predictable, and highly effective workflow where you pinpoint the exact point of failure in seconds. Let's trace the exact steps we take. Here is our final diagnosis playbook. The user clicks Log In. First, we make sure Preserve Log is checked, and we filter the network tab by fetch/xhr so we're only looking at the API calls. Second, we immediately scan the list for red text, and boom, we spot a failing request returning a 401 status code. Third, we click that request and inspect the request headers. We see a bearer token was indeed sent, meaning the browser did try to authenticate. Finally, we click over to the Response tab to see exactly what the server had to say about it.
And guys, this right here is the goldmine. You don't just rely on the fact that it's a red status code. Diving into the raw JSON response body gives you the exact specific reason the server rejected the user's login attempt. Instead of dealing with a super generic login failed pop-up on the UI, DevTools lets you see the server explicitly stating things like expired token or account locked due to failed attempts. Armed with that exact string, you know precisely how to resolve the ticket, and you don't even need to loop in Tier 3 engineering. By treating DevTools as your recording studio and the Network tab as your high-fidelity microphone, you are now fully equipped to methodically solve any HTTP mystery that comes your way. You understand the vital status codes, you know how to isolate the noise, you can read the timing waterfall like a pro, and you can easily separate a standard authentication failure from a browser-enforced course block. So I'll leave you with this final thought. The next time a user reports a broken page or a failed request, are you going to waste time guessing, or will you open the Network tab and simply inspect the truth?